As you see on the table here is all these tools that requirement for a service technician to have to working on a refrigerator. Let's first start with the multi-voltmeter, a pair of wire stripper, a pair of needle nose, a pair of channel lock, a pair of plier, I think this is called diagonal, a pair of multi-service screwdriver, a set of star head, flashlight, a turkey baster, a scraper, a small hole, your heat gun or maybe hair dryer, drill, whichever side you prefer, paper towel and some towel for cleanup. So that's all of the basic tool that we're gonna need for a technician to work on the refrigerator. Okay, let's look at on the table here. You have like about 6-7 components that's major in your refrigerator. Let's start look at the first one is the temperature control. As you see right here, we have two different temperature control. This one is for GE, a hot point. This one is for Whirlpool. And look at the defrost timer. And you got the defrost heater. You got the evaporator fan motor. You got the defrost thermostat or terminate thermostat. And you got the solid state relay for the compressor, overload protection, and this is your typical condenser fan motor. And this one you have is the mostly commonly used when you have problem with your relay or overload protection or some wrong with your compressor. It's famous for 3-in-1 stock. It can replace everything. It's got relay, overload, and the stock capacitor. So let's talk a little bit about the temperature control, how you testing it. On your temperature control, you have two prongs for the electrical wire connection. You got power going in one and coming out the other side. And you have the temperature probe to send to feel how cold it is in your refrigerator. And you got a control knob on and off position. So let's test this one. This is a hot point and see if it's working. Make sure you put your multimeter on ohm and continuity, or you just put on continuity. On continuity it's gonna make sound as you hear. So let's test this one. We put the one terminal lead to one side and touch the other side. We didn't hear anything, so it's in the off position. So let's turn it on. Now you hear the sound, that means it's good. Let's try with the Whirlpool temperature control. It's about the same style. It's just a little bit different on the probe and on the frame and on the connection, but it's got two wire connection too. Let's check it. It's also on an off position. Now you hear the sound, that means it's on the on position, so which is good. Now let's look at your defrost timer. This particular one is for the Whirlpool, and your hot point is almost similar to it. As you see, there's a diaphragm on top of your defrost timer. You got terminal 3. You can see the light go up to the amp, it's mean motor, and it go to the resistor, and it go to that black wire right here. That's your power wire. Go to your motor, and you have terminal 4 is normally closed to terminal 1, and between terminal 1 and terminal 2 is normally open. That tell you this number 1 is going to be your power source. Your number 4 is always closed. Let's go to your compressor, your evaporator coil, your condenser fan, and your evaporator fan in the running position. And when it's in defrost mode, it's open terminal 1 and 4 and connect terminal 1 and 2 to your heater, defrost heater in the evaporator coil to turn on the defrost mode. So that's the basic of your defrost timer. Let's test it between the prong and see between all the terminal and see what it's going to do. And same thing, you're going to test this with the continuity. First we need to make sure that it's in the run position. So let's check it. As we know, number 1 and number 4 is normally closed when it's in run position. You hear the sound, that means it's good. 4 and 1. You don't hear anything, so that means it's open, it's in defrost. So let's turn the down. You hear a click, so now you should hear between 1 and 4 go back to normally closed. There you go. And then between 1 and 3, that's your motor. You don't hear anything. And then between 1 and 2, you don't hear anything either. It's not in defrost mode yet. So if it's in defrost mode, let's turn it to defrost until you hear a click. There you go. You should have continuity between 1 and 2. There you go. So your timer is good. Let's look at this one. This is your typical defrost thermostat. You got 2 wires and with the clamp, so you can clamp on the evaporator coil. And you got 2 legs. It's the brown and pink. To test this, we always know that it's open when it's room temperature. So we're going to test it. As you see, it's open. There's no continuity. So we're going to come back with this when we make it cold and we can test it for you. And you see this, your defrost heater. You got 2 insulated wires, so there's no moisture go to it. To test your defrost heater, you need to set it on continuity. And you hear this one, you got nothing, so that means this defrost heater is no good. So we know this one is defective. Now you got your evaporator motor. Right behind here you got 3 connections. One for your common, one for your high voltage 110 volt, and one for your ground. To test it, We want to make sure there's no ground, so make sure you got continuity. Test your ground to ground. There you go. Between ground to this, you hear nothing. To this terminal, you hear nothing. That means your motor is not grounded. And then test between the two pron. You should have 78.2 ohm. That's what we see on the meter, 78.2 ohm. It will tell you on your diagram it's come with the refrigerator. That means it's good. Now as you see here, you have a solid state relay. With this type of relay, you don't have to do any test. Just shake it. If you hear a rattle noise, that means it's defective. Replace it. If you hear nothing like right now, the relay is good condition. This is your overload protection. You should test it with the continuity. You should have continuity between this and this. So that means the overload is closed. It's not open. And then you got your condenser fan motor. It tells you how many ohm is on the diagram. And to test it, you set your meter at ohm. Always start with the higher ohm and work your way down if you have the analog meter. With the digital meter, you only set at one range and it's automatically displayed. With this one, you got 179 ohm, as we see on the meter, 179 ohm. And with the 3-in-1 start, if your compressor is humming or try to start, it kick in, kick out every few minutes, every few seconds, or it's humming. I found the quickest way for me to do, as I've been doing this for quite some time, instead of checking all the relay and the compressor and the stock or run capacitor and the overload protection, I disconnect everything out. But first I make sure there's power go to my compressor. So when I know there's power go to the compressor, that means my defrost timer is working and my temperature control is working. That's why I got power continue from temperature control to defrost timer to my compressor. And you will know if you see your condenser fan is running. That means your timer is good, because they all came out from one source of power. That's when you disconnect the power or the breaker, unplug the connection, and cut the wire, reconnect as it tells you how to do on the body of the 3-in-1 starter, and it tells you exactly how to hook up and follow the direction. And after you finish, turn the units back on. If the compressor is running, the problem is solved. If it's not running, replace your compressor. If your refrigerator under 5 years old, call the manufacturer. It's still under warranty. They will come out and replace it for free, or you're gonna replace yourself and they send you a new compressor. And if it's older than 5 years and the cosmetic still look good and you know how to replace the compressor, go ahead and replace. If not, I advise you replace the refrigerator.